Okay, hey gems. Today we're going to be doing our properties of logs and exponential functions major grade video problems. As you go through, I highly suggest that you have out your 6.5 properties of logarithms notes, where we've got our kind of the properties on the left and all those practice problems on the back side. Those are going to be super helpful, so I'm going to have those out as I work through these as well. So we're going to do a couple practice problems together, and then you guys are going to do the rest on your own, just kind of like our last video that we did as well. So let's get ourselves started. So for part 1, we're going to condense and write the expression as a single logarithm, and then we're going to simplify if possible. So we want to make sure that we have only one word log, right, as we're going through, because that's what condensing means. So for each one of these, we're going to look at which property it is, and then we're going to go from there. So since I have this 2 in front, I can take this 2, this is the power rule, I can take this 2 and bring it right over here above the 10. And I don't have anything over here that I can do with that one, so I'm going to rewrite this as log base 3 of 10 to the second power minus log base 3 of 4. Now we know that 10 squared is really 100, right? So I'm just gonna put a little 100 here in the parentheses. And then if I'm subtracting, what I'm really doing is I'm doing the quotient. So I'm dividing these two. So this first one goes on top, it's the numerator. The second one goes at the bottom, it's the denominator. And since they have the same base for their log, I can just write it one time, log base 3. And then I've got 10 squared, which is really 100 divided by 4. And then I can simplify. I know that 100 divided by 4 is really 25. So my final answer is log base 3 of 25. There's my first answer. Okay. Number 2, we've got a couple more properties now as we go through. So I've got log base 3 of 4 plus 2 log base 3 of x minus log base 3 of 5. So when you have more than one operation, order of operations just as you work from left to right because they're addition and subtraction. So you just work your way from left to right. So if I'm adding, what I'm really doing is multiplying. But in my first one here, I've got nothing I can do, but in the second one, I do see that there's a 2 here, then that's the power rule. So I can take this 2 and I can bring it up, so it's actually an x squared. And then I've got log base 3 of 4 plus log base 3 of x squared. What I'm really going to do is multiply this 4 times this x squared. So I'm going to get log base 3, and then 4 times x squared is 4x squared. Okay, and then I'm just going to bring down the minus log base 3 of 5. And then from here, I know that subtraction really means that I'm doing the quotient rule. So I'm going to take this top one and put it, or this first one and put it as the numerator, the second one and put it as the denominator. So I'm going to write log base 3 of 4x squared divided by 5. And I go, okay, can I simplify that further? I cannot. So I only have one variable and I can't simplify it further. So there is my final answer. All right, one more example together. Number 3. Okay, log base 4 of 6x minus log base 4 of 10. So again, I know that subtraction really means that I'm going to be doing the quotient rule. So I'm going to be dividing. There's no power rule or anything funky, so I'm just going to leave it how it is. I've got log base 4 of, here's my numerator, 6x. And my denominator is 10. And then I look at that and I say, okay, can I simplify that further? I can. 6 and 10, I can divide them both by 2. So I've got log base 4 of, so 6x divided by 2 is 3x. And then 10 divided by 2 is 5. I can't simplify that further. I have one variable, so I am finished. Okay, so now you're going to take a moment. You're going to pause the video. You've got 2 problems that you're going to condense and write the expression as a single logarithm. So go ahead and pause the video and give it a try. Okay, now for our second part, for part 2, we're going to do just the opposite of what we did in part 1. So instead of condensing our logarithms, we're going to now expand our logarithms. And we're going to make sure we do it completely. So we're going to simplify if possible, but we're going to expand. So you might have the word log more than one time, and that's okay because that's what expansions are doing. Okay, so for the first one, I've got log base 10 of x times y squared. So I go back to my little properties sheet, and I know that if I am multiplying, the product rule says what I'm really doing is I'm adding the two of those together. So I'm going to rewrite this as log base 10 of x plus log base 10 of y squared. So this one's expanded completely, and we don't actually really even need to write the 10 because it's assumed that it is a base 10, but you can if you want to. The only thing that I do see is that this right here is the power rule. So I can take this 2, I can move it to the front of that equation there. So my final answer is log base 10 of x plus, bring the 2 in front, so it's 2 times log base 10 of y. And I can't expand it any further. I've got my 2 logs, got them separated. So that is my final answer for the first problem. Okay. Now for number 2, what I've got going on again is I see that I've got multiplication, right? And so if I'm multiplying, I know in the back of my brain, I'm really going to be taking these 2 logs and adding them. Now this log does not have a base, so it's assumed that it's a base 10. If you want to write it in, you can. You do not have to. It is not required. Okay, so I'm going to rewrite this as log, and I'm not going to put the base 10 because I know it's a base 10, log of 3 plus log of 2 to the 3rd power. Now I'm not going to actually do 2 to the 3rd power because that's exponential. What I'm trying to do is write it in log form. And so I'm going to take this 3 because it's the power rule, and I'm going to bring it to the front of my equation. So I've got log of 3. Again, you can put the base 10 if you want. Plus, bring the 3 to the front. So 3 times log of 2. And I've got 2 logs, so I'm done. That's my final expanded equation. Okay, now let's do one more together. Now this one looks a little bit different because it is an ln, and ln means natural log, but we're gonna kind of go about it the same way that we would for a normal log. We're just gonna make sure that instead of writing log, right, like up here, log base something, we're gonna write natural log and natural log. Okay. So I've got division here, and division means that what I'm really going to do is I'm going to subtract the 2. So I've got the natural log of 2x squared minus the natural log of y. Now here's where it gets just a little tricky, but you just got to be careful. So this right here is actually multiplication. 2 times x squared. Well, I can break down multiplication to really be addition. So I can break down this to be natural log of 2 plus the natural log of x squared. And then I bring down my minus natural log of y. So now it's kind of broken down into the further pieces, but I still see one more thing I can do, which is the power rule again. I'm going to bring that to the front of just this equation right here. I'm sorry of the noise. That is a truck passing by. Ms. Masso has her windows open at her house. Okay, so this stays natural log of 2. Bring the 2 in front. 2 times natural log of x minus natural log of y. And there's my final answer. Okay, so now you are going to try the following 3 problems. So go ahead and take a moment, pause the video, and give them a try. Okay, now for part 3, don't worry, we're halfway done. There's only 4 parts. You're so close. Okay, 50%. Okay, for part 3, we're going to condense the equation. and then we're gonna solve for x. So we're gonna condense it first, solve for x second, and you'll see why it's gonna be way easier if we do it that way. Okay, the first one I have 7 to the power of, so this whole thing is power, right? Log base 7 of 5 equals x plus 12. Now, if I look over here on the left, this rule looks like something that we've learned here, the exponential logarithmic inverse. So what it says is if this base and this base are the same, essentially these two kind of cancel each other out, and I'm just left over with what's right here, right? So if these, the 7 and log base 7 kind of cancel, I'm just left with a 5. So these kind of cancel, I get a 5 equals x plus 12. And oh my goodness, oh, I should hide the other one, sorry. So simple from here, because now it's just a regular old algebra problem, and all I have to do, friends, is get the x by itself. I'm just gonna take this plus 12, I'm gonna subtract 12 from both sides. Okay, they cancel over here. So you get -8, right? Equals x, and then that's it, okay? Or sorry, whoa, oh my God. I was like having a moment. I was like, this doesn't seem like -8. -7, excuse Mr. Mouse. She's having a moment. All right, so 5 minus 12 is -7, nice. Okay, and that's it. So essentially, once you condense the one part, it should kind of break down to be just a number. And then if it breaks down to be just a number, the rest of it's super easy to solve. Okay, so let's try number 2. Don't be alarmed because it looks so much bigger, but it is still just as simple as the first one. So what I'm gonna do is I'm going to condense the equation as much as possible. And so what I see here is I've got log base 10 of x plus log base 10 of 3. Now, I know that if I'm adding the two together, then I'm doing the product rule, which says if they have the same base, which they do, log base 10, I just take the two results here and I just multiply them together. So x times 3 is gonna give me 3x. So I've got log base 10 of 3x equals log base 10 of 12. Now here's the really cool part. When you've got logs that are exactly the same, they kind of cancel each other out and you're just left over with the results. So because this is a log base 10 and this is log base 10, it's the same base, I just go with here what my result is. So I've got 3x equals 12. And then all I do from here to solve for x, divide by 3, I get x equals 4. Okay, so when the bases are the same, okay, and my equations are equal to each other, I can just set my results equal. Okay, so that's what we did here. We took our 3x and our 12 and we just set the two equal and we solved for them. And that works every time if you have the same base. They'll essentially cancel each other out, which is really nice. Okay, now let's do our last one. Number 3. I've got log base 9 of 9 to the 11th power minus log base 4 of 64 equals 2x. So we're gonna break down the right side first before I try to solve for anything over, or excuse me, the left side before I try to get myself over to the right side there. So if you look at your properties of logarithms here, when I've got two of them that have the same base, this is just a foundation, right? 9 to the 9 to the 11th power. So essentially I go to myself, okay, if I have a base 9, 9 to the what power gets me to 9 to the 11th? Well, it's just 11. So essentially, the log 9 of 9 kind of cancels. You're just left over with the exponent. So log base 9 of 9 to the 11th is just 11. Oh my gosh, look how easy that was, ready? Then over here, I could do this, right? Because it's subtraction, I could make it into division, but look how easy this is. Right now I've got log base 4 of 64. So in my brain, I can think, remember we did this in class, right? I can think for my base to the what power gives me 64? Well, it's 4 to the third power gives me 64. So my answer to this little piece right here is just 3. Oh, so look at this. So I've got 11 minus 3 equals 2x. And now it's really easy to solve. So now I've got 11 minus 3, come up here, gives me 8. 8 equals 2x. And then to solve for x, I just divide by 2. Divide by 2. I get x equals 4. Okay, so once you condense the equation, what should happen is it should come out to just be a number, and then it should be very easy from there to kind of get yourself going to solve the actual equation. So make sure you condense first and then solve the equation. If you try to do it the other way, it's not going to work out for you. All right, so again, I'm going to have you take a moment here. See if I can zoom in just a little bit more. Take a moment, pause your video, and give those 3 problems a try. Okay, so I folded it over a little too hard. All right, now we're on our last section. You guys should be so excited. Okay, so for part 4, whoops, it would help if I'm in there. Part 4, we're gonna evaluate without a calculator. So we're gonna actually figure these out. We're not gonna put it into our calculator. You can put it into check, but we're gonna evaluate without one. So we're gonna get ourselves down to just a number for each one of these problems. Okay, so essentially it's just like kind of what part 3 was, except I don't have it equal to an equation over here. I'm essentially just condensing what I have, and that's really it. Okay, so over here, this is a foundation, log base 3 of 3 to the 5th. This just says 3, my base 3. 3 to the what power gives me 3 to the 5th? Oh, well, obviously, it's just 5, right? So this right here just becomes 5. And then I come over here and I say plus, all right, 5. So again, we're thinking, here's what I'm thinking in my brain. 5 to the what power gives me 125? Well, it would just be 5 to the 3rd, right? Gives me 125. So the answer there is just the 3. So 5 plus 3 equals 8. And we're done. Easy peasy, right? Easy. Let's try the next one. Looks a little bit different. So for this one, I've got myself multiplication, okay? Now, here's the issue with these two. I've got multiplication, but this one is a log base 2. This one is a log base 6. So they are different bases, which means I'm gonna have an issue because I can't actually add them together or multiply them, right? They have to be the same base in order for me to do that. So what I'm gonna do is I'm gonna change the base of this one right over here, log base 2 of 6. That is my property. It's actually called the change of base property. So in order to do that, I'm gonna take these two numbers, right? The number that is my base is the denominator. It goes at the bottom. The number that is the result, the 6, right, goes at the numerator. It goes on the top. So if I were to rewrite log base 2 of 6, I would rewrite that as log of 6 divided by log of 2. Okay, now I'm gonna do the same thing for this problem over here. I'm gonna rewrite log base 6 of 8. I'm not gonna forget to put my multiplication. Now when I rewrite it, this second number over here goes on top. So it's log, did I mess this up? Oh no, I didn't. Log base 8. Okay, I'm having a moment here, guys. All right, and then the base goes at the bottom, log of 6. Now, if I go, and I'm doing multiplication, when I multiply with a fraction, I go straight across on the top, right? So I have log base 6 times log base 8, and log base 2 by log base 6. But before I actually do that, I'm just gonna take a moment, I'm gonna go, oh my gosh, look, I've got log of 6, log of 6. Because one's on top and one's at the bottom, they're essentially going to cancel. So I'm just left with log base 8 over log base 2. Now, I'm going to take it from this form and I'm going to rewrite it to look back like this. So I'm going to go back to the change of base form. I'm just going to go the opposite way. So this 2 becomes the base, log base 2, and then the 8 becomes my number on top, log base 2 of 8. So now I go, oh my gosh, that's something that I can actually evaluate. Because if I think to myself, 2 to the what power gives me 8, well, the answer is just 3. 2 to the third gives me 8. So my answer here is 3. All right, let's go to our last problem, and then you're done. Okay, I've got log base 3 of 1/9 minus 2 to the power of log base 2 of 3. So let's look at each one of these individually. Let's just look at this piece first. Okay, I say to myself, all right, the base is 3. I say, I'm thinking, right? This is what I think. 3 to the what power gives me 1/9. Now, because it is a fraction over here, that means my exponent is going to be a negative number. So to get from 3 to the what power gets me just to 9, that would be a 2. But because it is a fraction, I move it from the top to the bottom. It's actually a negative 2. So, right, 3 to the negative 2 gives me 1/9. So my answer for this one part is just negative 2. Good. Now I'm going to come do this part over here, minus. Okay, 2 to the power of log base 2 of 3. So this is that exponential logarithmic inverse piece, which says 2 to the log base 2. These two kind of cancel each other out, and I'm just left over with 3. So then my final part is to just evaluate. Negative 2 minus 3 gives me negative 5. And I'm finished. So now for your last problems that you're going to do, you've got the 3 that are listed there that you should notice look very similar. So you're going to evaluate them without a calculator. You should come up with one final number. And then that's it for our video. So you can pause it here and then practice those problems and hopefully get yourself a really great major grade on properties of logarithms. All right, have a grand day.